Hello folks, this is tutorial number 9, which is called the sliding ladder mechanism, and these go into a playlist which are called kinematics in 3D Experiences platform. Now, what it is, a ladder which is leaning against the wall and it's sliding along this horizontal floor. Okay. Now, it may look familiar to you because when you took your first calculus class, your instructor might have done this thing under the subject of related rates problems. And the way it was done is that the height of the ladder and the horizontal distance of the ladder, z and y, uh, if you use Pythagorean's theorem, you say z squared plus l squared equal to length of the ladder squared, and you differentiate both sides of this thing. The right side is going to be 0 because L is constant, and the left side is going to be 2zz dot plus 2yy dot, but you can divide through uh, by, uh, by 2, and you get this expression. Now notice that if you know the displacement, the velocity, if you know the velocity of the top of the ladder, namely if you know z naught, such as, for example, a constant velocity downward, then you can calculate the horizontal velocity of this bottom point at the center of the circle at the very bottom using that expression. Now notice that that's not constant. Even though this ladder may be sliding down at a constant rate, the horizontal rate is not going to be constant. And in fact, it comes from here in order to uh, get the expression for y, uh, y dot, you have to know where the ladder starts from. That's why there is a velocity and there is a position z naught, and then the information about the velocity of this center point in the horizontal direction comes from that, and the acceleration comes from the one on the right side. So this was done for you in your calculus class. Now, the way I'm going to do this problem, although this is not the only way, there are several different ways of doing it. One of them, because I want to introduce these new joints to you, I use a point curve joint. So the center of the circle travels along a line here. That's why it's called a point curve joint, a point and a curve. The bottom one, also the center, is also traveling along the horizontal line, but I'm going to do it differently. I'm going to create a slide curve joint because you can notice that this circle slides along that horizontal path, okay? So that's how I'm going to do that. Point curve, slide curve. But there are other ways of doing it. This is the contents of chapter 5 in the textbook that I did about 9 years ago, but the textbook was not updated. It was released 2016X. That's almost 9 years later. So instead of revising the book, I decided to do these tutorials and basically show you the new interface and functionalities after 9 years of development. Okay, let's go ahead and do that. Okay, so I started with an assembly, and I'm going to insert my first part, which is going to be the wall basically. So insert the 3D part, and let's wait for it. Okay, I can rename this thing so that it says wall, but I'll leave it the way it is. So the first one, this first one is going to be the wall. So let me go into the 3D shape and make that wall, which is an L-shaped area which has been extruded basically. So let me make an L-shaped profile here, like so. Okay. Now let me see what this dimension is. I'll make this thing 100, although it doesn't matter. Okay, and we're going to exit and pad this thing by 20 millimeters. There we are. Now, on this face, I will draw a line basically. And the reason I do this is I need to create a point curve joint, and of course I need a point, which I will create later, but I also need the line. So let me go ahead here. So on that face I will sketch. This is the easiest way of doing it. There are other ways obviously, so I'm going to draw a line here, vertical line. Okay, and let me bring this thing and put it on that line. This control that, and you get a dimension, and right click coincidence from here to here. This is to be 10 millimeters. All right, and let me make, I don't think these are, yeah. So let me make this thing 100 millimeter. Okay, good. Let's exit. So I have my line here. You can see that there is the line, this line. Okay, we're done with that. So now we're going to insert our second 3D part. Insert 3D part, and this is going to be the ladder. So double click on it on a convenient plane on that on the back plane. Back plane meaning this. I'm going to sketch something that looks like a ladder. I'll use elongated hole to make my job easier. There we are. Let's dimension these things. This is 100, and the radius at the end is 10 millimeters. Okay, exit, and we can pad this thing by 20 millimeters. Now I'm going to create 2 points here. One of them is going to be at this end. That's going to be using that's going to be used for point curve join, and another point down here. And the purpose of this other point is to be able to plot velocity, acceleration, stuff like that for this bottom point. Okay, so let me create a point, and the method of making the point is circle center, and I'm going to select that. That's my first point. And I repeat this for the other end. Again, circle center. That's going to be the other one. We go all the way to the top. And now we try to assemble this stuff. We are at the assembly level. So first let me fix this first 3D part, my wall. So I go to engineering connection, expand this thing. There is a fix here, anchor basically. So that whole thing is going to be fixed in space. Okay. Now to put this point on that line, here's what I'm going to do. I'm going to go to the different ways of doing it, but I'm going to go to engineering connections. Engineering connections. For a second. There. And I will use a coincidence. There we are. User defined coincidence. And I'm going to take this point and coincide it with that top point. All right. Cancel that. Oops. Yeah. And then do it again. And this time I'm going to be contact. I could have done it in the previous dialog box, but it's okay. One. Say okay. We don't want to do any contact, and then we update. There we are. Okay, there are the different ways of doing this thing. But, all right, let's move on. Now, these two constraints that are created, I'm going to delete because the sole purpose was actually to put them in the right spot. I don't want to. I don't want to cause a complication later on, so I'm going to delete these. Delete that. Very good. Okay. So now we're going to go to this application, mechanical system design. This is for creating mechanisms. And notice that, by the way, yeah, here is a mechanism. Here's a mechanism. I can do it now, or I can create the point curve joint, etc., and do it later, and do the mechanism later. So let me actually go ahead and do that. So let me go ahead and click on engineering. Before I create the mechanism, I'm going to click on engineering connections, and I'm going to use the pull down menu, find the point curve joint, and I'm going to use this first uh, a template, point and a curve. So there's the point and there's the curve. Okay, and I don't want to do any contact calculation. Now let's do a slide curve here. So we do another engineering connection, pull this thing down and get the slide curve. I select this bottom half a circle and this line, a new connection, and then we say okay. I don't want to do any contact either. So these two, let me update these things and see what happens. There's a point curve, there's a slide curve. There. Now, I don't particularly like this message that I'm getting, and I, I honestly try to trace it back to see what is it that's causing a problem. So eventually, what I decided to do is I will double click on this. See that? Double click on point curve. See, there is this lock here. So let me unlock this. And lo and behold, it's going to work. So I don't see any reason why I'm getting this, but let me unlock that. And then we say okay, and then update. That's going to be gone. I don't like it, but that's the way it is. Okay, so now we can go and create our mechanism. And you don't have to select the second tab because it's automatically selected, and then we say okay. All right. And now if you want to check to see what actually happened, if you click on the mechanism manager, you see that the fixed part, here's the point curve, and here is the slide curve. Now, this slide curve right now, it says it's length driven, so I don't want it, so I'm going to uncheck those. But the point curve, I want it to be length driven, and it is. You can see that. Okay, so we say okay, and if you go into there one more time, you see that that check mark is green, which means we're in good shape. Now let's check something out. Here is the mechanism player. Let's check it out. Okay, notice that it says right now I'm 100 millimeters. So actually you can see that the point zero is down here, but it really doesn't matter. If you move this thing, you see that it goes to where it's supposed to go, okay? And reset, okay? So remember, this is the point 100 millimeter, and this is the point zero, okay? Because probably, that's the way I probably made it. I can't remember, but anyway, let's go ahead. Now, we're done here. So we're going to go to the mechanical systems experience. Say okay. Kinematic simulation. We're going to create a scenario in a minute. Okay. Now, first thing we want to do is to specify the formula for the velocity of this point, which is going down 100 or 10 millimeter per second. Let me remind you, 10 millimeter per second, and it's going down. So we're going to go to low excitation, select the support. The support is that command that makes it point driven. Notice that right now, if I click on f of x, because I want to enter the formula, if I click on f of x, it says right now this is equal to 100 millimeter because that point at the top. I can say minus 10 mm underscore s times time. So as time goes on, that 100 millimeter is going to get reduced at that rate, which means it's going to go down with that velocity. You say, okay, good. Now, I also want to create a probe here because I want to plot the velocity of this point and acceleration of this point in the horizontal direction. And the probe is done right there. Position, speed, acceleration, probe basically. Okay, that's what it is. Okay, and we select that point and then we say okay. All right. Now we go and create a kinematic scenario right there. See that? Right there. Okay, it says that you created one excitation, that formula. You want to use it? Yes. Send it to the right. Look at the probe. You created one probe. You want to use it? Yes. Parameters tab. I want to do a simulation of 9.5 seconds and step off point oh 0.05, okay, or yeah, 0.05. So otherwise, the curve that we generate is going to be jagged, etc. But that's okay. We say all right. Now we go compute and generate. You click on it. There is physics here. This is not a cartoon. There is a physics. That point on the top moves down by at the speed of 10 millimeters per second. This is a warning because it didn't go all the way to the end, but that's okay. We close this. Now we can click on this view scenario results. I don't want to see everything, so I did deselect all. I want to see the acceleration in the y direction, velocity in the y direction, and acceleration in the y direction. Okay, and I better get this kind of a, I mean, it should match this. Okay, so I want these two things to be plotted. So if I click on the plot tab, there we are. So this one is the acceleration. It's negative. Notice that the scale here is negative. This is the velocity, and it's going to zero. Velocity is going to zero because that point at the very end of the ladder eventually will stop because the ladder becomes horizontal. So this can be compared with this kind of information. For example, V naught is 10, and initial height that was Z naught was 100, and the length of the ladder you can work it out. It should match that, and it will. And that takes care of. Oh, let's actually do one more thing. Let me go back here. Let me close this. Suppose I want the trace of a point right there, okay? Trace of a point right there. So what I'm going to do is I'm going to go to that part, and I create a point on this surface, maybe here, there, and I say okay, all right. Now let's go back to our scenario, okay, back there. Now here is the for the trace. We go to the result. We go to the results. Actually, we have to go to results. Are we in the results here? Sorry, I have to double click on the results right there. Left double click on the results, and there's the geometric trace. And I'm going to select this point, and I say, okay, show me the trace, the path of that point. Okay. And if you want to see it better, so copy this, and you go here, and you paste it. There we are. So as time goes on, this point will follow that path, and let's check it out. So we go to our scenario, and let's animate this thing, play simulation. Okay, there we are. I clicked on play simulation, and we gradually increase this. That point, that point, that point in the middle will follow that path. You see, at the very end, it's right there. And one last thing that I want to do is, suppose I want to find the volume of this whole thing. What is the volume that this is sweeping? So I click the swept volume. This thing comes up, and this is the element. There's only one thing that's moving, and that's going to be used. Okay, there's only one thing that's moving. And say okay. And there is the swept volume. That connecting that ladder will sweep a volume like that. Well, again, you can, if you want, you can copy this thing and go to that part and paste it there. There we are. Okay, folks, this is it. Good luck.